16 and AR-15, when they first came out with a 20-inch barrel, really ran pretty good. The long gas tube gave enough of a delay so that the pressures could be reduced in the chamber. The bolt would open when it's supposed to, the bullet would extract like it's supposed to and eject. It wasn't until we started shortening the barrels down, and now all of us want a shorter barrel gun, that they started having some serious issues. So what is the problem with having a short barrel on a gas impingement gun? It's really not the barrel, it's the short gas tube that goes with the short barrel. The gas tube being shorter throws the system off, pressures go up, and the timing is off. To really understand what the problems are, you have to understand exactly how the system works. And it's all about timing, and it's all about pressure.
When you pull the trigger and fire a round, the brass casing swells with explosive force, pressing hard against the chamber walls and bolt face. It's only when that gas escapes through the muzzle and the gas tube that the pressure is reduced in the chamber. Now that the brass is again relatively loose in the chamber, the bolt can unlock and a spent case can easily be extracted.
When you shorten a gas tube, from Eugene Stoner's original specifications, you throw the whole system out of whack. The way manufacturers of gas impingement ARs have dealt with this problem is not by correcting the timing, but with brute force.
Our goal is to not have a way overpressured firearm, and I see lots of them all the time, where gas ports and barrels and then the gas block system is opened way up and you got huge bolt speeds.
The first thing they did was open up the gas block to increase pressure on the action. This got the system to unlock, but extraction was still an issue.
With a short gas tube, the gas gets to the action too early, and the bolt is forced to unlock and extract while the chamber pressure is still high and the casing is still pressed against those walls. That extra friction causes the failure to extract malfunction.
To solve the extraction problem, the next step was to add a heavy extractor spring, and later modified with a rubber O-ring, to increase the extractor's grip on the case rim, so that even though the casing is still under pressure, it could be ripped out of the chamber. So now, instead of unlocking and extraction problems, we get worn and broken locking lugs. We see broken extractors. And especially with civilian ammunition, we see a lot of blown primers and case rim failures. All right, but it doesn't end there.
Not only is the weapon cycling earlier, it's doing so under much higher pressure. And with more force comes more speed.
The extra force that we applied to the action greatly increased the bolt speed. The bolt carrier group is moving at a much higher rate.
This results in the failure to feed malfunction, due to the bolt outrunning the magazine's ability to feed the next round properly.
So now we need to reduce the bolt speed and get this thing to feed. So to reduce the bolt speed, heavy buffers were installed. To try to correct the feeding problem, there's been a whole slew of expensive so-called high reliability magazines that have been developed. History tells us that magazine reliability was never an issue with the 20-inch AR-15. The bottom line is that none of these fixes are actually addressing the real problem, which is proper gas regulation.